Hello guys, this is my second video which is related to the networking part, your advanced level syllabus. If you didn't watch my previous video, please go to the video 1 and watch it and join with this lesson. And here I'm going to explain you the properties of the signals. So what are the properties that we must know when we talk about data communication and print signals. So let's see. First, you must know what are the properties. There are a few types of signals, or what are the properties of signals, or there are a few types. So one is called amplitude. Then you must know what is amplitude, and the second one, the frequency. It is very good thing. What is frequency? What is the measurement event of it? And wavelength is the next one, and the last one is phase. Let's learn one by one. So here, what is amplitude actually? So amplitude, what is amplitude? When you talk about signals, what is amplitude? Why we need that one? So as example, when we hear some sound, sometimes a sound can be soft one, or another one is loud one. So there are two different things. When you talk loudly, then your sounds is loud. If you say something softly, then your sound is also soft. Then amplitude, the measurement of the distance between peak or through, right? That means top of the wave and the valley or a bottom, right? So that is the amplitude. Then this is the diagram which is represented two signals with amplitude. Then first one is soft sound, and the second one, the amplitude is also high. Then you can see that one using blue color here. Blue color arrows are used to represent it. Then check this one. When you talk about this one, here amplitude is less and here amplitude is high. Then this sound is louder than the first image. Right? Then I think you have the clear idea. Right? So next. Explain further. Position of the medium at representing water or a sound traveling in the air. The maximum displacement of points on a wave. Amplitude means the maximum displacement of a point on a wave, or this maximum displacement is measured from the equilibrium position actually. So this diagram will explain you the equilibrium position, that you can clear what is amplitude. So what is equilibrium position? The straight line represented by x-axis. When you draw some line through the x-axis, right, that is called equilibrium position, and maximum displacement is called amplitude. I think that is clear for you. Next, move to the next one. What is wavelength? That is also very important here. So distance between two adjacent peaks or two adjacent valleys. We learned in the previous part what is adjacent peaks or valleys, right? So here, the time required to complete one full circle of the wave. So we know when we talk about signals, then we need to complete one full circle. The time required for it, then we can call wavelength. Look at this diagram. In here, I have shown you the wavelength here, right? So I think you can understand. So look at this first image. This is the two adjacent peaks here. We measured top of the wave. In here we have a full circle. And the second part, that is valleys. The two adjacent valleys here. Then that is called wavelength. I think that is clear for you. So what is frequency of a wave? That is very important. Frequency. When you talk about computer system, the computer speed also measured by the hertz. Then hertz is used to measure the frequency. This is called the number of waves that pass fixed place in a given amount of time. The unit for wave frequency is hertz. Then you can see these two images. When you talk about first image, then that is called high pitch Y. A number of waves in here are higher than the second pitch. The second pitch we can call as a low frequency or a low pitch because the number of waves are less compared with the first image. Then that is simply understand what is frequency. Last, what is phase? The phase means what? Existence of transmission signal in a wave for a certain time is called phase. Here you can say phase shift. This is considered as phase. Existence of transmission signals in a wave for a certain time is called phase. Then we have learned few things. What is amplitude? And what is frequency? And what is phase? And what is the wavelength? If you get those things very well to your mind, then let's learn something. What is propagation speed? The time spent to reach a certain direction through a media used to transmit data. This speed is changed according to the transmission media. So why do I say so? Also, when we are using so many types of transmission medias, such as transmission medias can be divided into mainly two parts we know, and the guided media and the unguided media. When you talk about guided media, so fiber optics are used to transmit waves as light waves, and that is the best data transmission media in the world. And comparatively, so propagation speed is different from each other. And time spent to reach certain directions through a media used to transmit data, and that is simply called propagation speed. That's all. Let's learn some comparisons of analog and digital signals. So what is analog signal? In there I have explained in my previous part also, noise is the primary disadvantage when we are transmitting analog signals, because outside noise is mixed with that signal. It is disadvantage. And digital signal noise is much easier to filter out. That if you want to remove the external noise, then you can do it easily if you use digital signals. But analog not like that. Signals are continuous. The analog signals, then you know the shape of the analog signal. It's continuous. But digital signal is discrete. We told it. Discrete signals are used, ones and zeros. Analog signal is continuously variable, but digital signals based on zeros and ones, we know it. Less bandwidth and capacity than digital. When you compare with the digital signal, less bandwidth is required to transmit data as analog signal. But greater bandwidth is necessary and the capacity than analog. So if the bandwidth is high, then capacity must be high. Then high bandwidth and capacity must be wanted. Analog in the real world, the sound waves, the water waves, and we can call as analog waves. But digital, mostly used in circuits, such as ICs and processors, microprocessors, whatever it is, they use digital signal. Let's learn something about, there are two different signals when we are transmitting data into one place. So the previous video I have explained you two types of signals called analog signals and digital signals. By using those type of signals, then we can call those two signals as baseband and the broadband signals. So first of all, you must learn something about baseband signals. Here, what is baseband signals? Actually, what is baseband signals? If you are using digital data to convert that signal, we can call digital signal. Signals are created using data. If you are creating some signal using data, that is called baseband signals. And second one, the based on digital wave. This is based on the digital wave. I think you know what is digital wave. And it is bidirectional. That means you can send data for one directions, and two directions we can send and receive data. That is why we can call this is bidirectional. And transmission short distance actually. We cannot transmit long distance using digital signal. due to frequency level is very low. When you talk about the digital signals, the frequency level is too low. That's why when you are trying to transmit digital data to long distance, that is a very bad thing. Attenuation is there. That's why attenuation of the signal can be happen when we are transmitting long distance signal. So they are not recommended for you. Baseband signals are not transmitted data one tower to another or one place to another for a long distance. That is the case. The several baseband signals cannot be transmitted through transmission media at the same time. But when I talk with you the analog signals, we can do the multiplexing part there. That means several baseband signals we cannot transmit like that. Because baseband signals, if you are transmitting one digital data, you want high bandwidth and high capacity. And when you are trying to transmit few baseband signals at the same time, you cannot do it. But analog signals we can do. That's why we can say several baseband signals cannot be transmitted through a transmission media at the same time. Important to remember that one. Let's something about broadband signals. Actually, broadband. What is broadband? Then you can clear by using this diagram. Then you can see the first here digital signal. So what is baseband signal? If you are talking about digital signal, we can call those type of signals as baseband signals. What is broadband signals? That means analog signals simply. The broad signals exist as a log signal. That is why we can call those type of signals as broadband signals. Ability to be transmitted through a cable or radio wave. Actually, we can be transmitted broadband signals through a cable or a radio wave. So we are experiencing that thing. Several broadband signals can be transmitted through a transmission media at the same time. Comparatively, this is good. Multiplexing is there. I told you the previous part, if you are using baseband signals, several signals we cannot transmit at the same time. So that's all. Thank you for watching this video. If this is useful, please subscribe my channel. Then you can watch so many videos one by one, and you can cover your syllabus and do some past papers, and you can achieve your targets. Let's meet on third video. Then I will explain something for you. That's all. Bye.